Right, now, boys and girls, now let us now look at the last question here in this paper. That is question 4.4. Determine an equation of a line parallel to PQ that passes through M. Determine an equation of the line parallel to PQ that passes through M. Of course, this one will say now, you remember now, the equation of a straight line is y is equals to mx plus c, or one can say now y minus y1 is equals to m into x minus x1. Right, now, what are we going to do now? Of course, you must ask yourself, to say now, if I want to determine the equation of a straight line, what is it that I need here? You agree that this is the gradient, right? This is the gradient, this is the y-intercept, or y value on that line, or you need a point, you need a point on that line. The same apply. It is the gradient. It is a gradient, and also to have x1 as well as y1. These two now you must have a point on that line. It is very important. Of course, now let us look at this one. They said you must determine the equation of the line parallel to PQ, and that line passes through M. Then here it's our M. You still remember what are the coordinates of M? Yes, the coordinates of M then was 1 and 1. That was the midpoint. That was our midpoint of PR. Right. Boys and girls, now how do we determine the equation now? Now, this is very important now. We are told now this line is parallel to PQ. It's very important. Remember, I've mentioned to say, always remember now, for you to have the gradient, you must have the 2 points. For you to have the gradient, you must have the 2 points. But in case where you have 1 point, then you must check the following. They will mention to you to say, this line is parallel. And also, if they don't say parallel, they will say it is perpendicular. Right? Now, to determine the gradient of the parallel line as well as the perpendicular line, what is it that you need now? You remember for parallel line, they have the same gradient. Now here we say M1 is equals to M2. If you are told that lines are parallel, now you must remember that they have the same gradient. They have the same gradient. Now the same applies with what? If the perpendicular lines. If you are told that lines are perpendicular, then it means M1 multiplied by M2 is equals to a -1. Therefore, now this will enable you now to have what? To have the gradient of that line that you want to find the equation of, right? Good. Now, let us look at this one now. We have the gradient of PQ. What is the gradient of PQ? The gradient of PQ, you said is equals to what? Is equals to 4. Right, you said the gradient of PQ is equals to 4. Now, it means the gradient of PQ is equals to 4 is equals to then the gradient of what? Of the second line there, which passes through what? Which passes through M. Then now we can now say y minus y1 there is equals to m into x minus x1. Now you substitute the gradient, which is 4. Good. And then from here, x minus. Now you take x1 from here. That will be x1, y1 minus 1, and y minus 1 on this side. Now we have 4x minus 4. We take 1 on the other side. It is plus 1. Therefore, y is a 4x minus. Y is 4x minus 3. Y is 4x minus 3. Okay, thank you very much. Now, boys and girls, remember now, this is very, very important. The same apply. If they said it's perpendicular, then you remember now, okay, that is 4 multiplied by M2 is equals to -1. You just divided the 2 by 4. Therefore, M2 then will be -1 over 4. Right, boys and girls, I tried on this first session to make sure that you really understand how to use your formula and make sure that you interpret questions correctly. Right, now, before we take the break, I think which will be in 4 minutes time from now, let us quickly look at this question. Before we take the break, let us quickly look at this question. Boys and girls, now it's very important to read the instruction name. Very, very important. ABC is a triangle with the vertices A, B. I'm interested at B. What are the coordinates of B there? It's 2 as well as 0. and C, it's a P and minus 4. With P being greater than what? 0. Then in the Cartesian plane, AB makes an angle of 45 with the positive x-axis. Immediately I see this one. What comes in your mind? Of course, that is the angle of what? That is the angle of inclination. It's very, very important. Now the last part is AC is the square root of 50. What is this one? Of course, it's not a gradient, it's not a midpoint, but it's a what? It is a distance. Then the distance between AC is a square root of what? It's a square root of 50, right? Boys and girls, now you can see now in this diagram, in this case here, we have A, we have B, we have C. Then everything now it has been represented correctly. What is the first question? I think it's a 2 marks. I think this is the question that will lead us to the break. Okay, the first question says, determine the gradient of AB. Determine the gradient of AB. How do you determine the gradient of AB? You must have the 2 points, A and B. Good, is that correct? Yes. Now, here are the coordinates of A. Are you happy with the coordinates of A? Yes, I can see that A, the coordinates is 1 as well as what? 1 as well as 3. And now, what about B? Then B, are you also happy with B? No, I can see you are not happy. I can see you are not happy. What is the reason? Yes, you don't know what is the value of T, right? You don't know what is the value of T. Therefore, it means we cannot do what? We cannot use what? We cannot use the gradient formula to determine the gradient of AB, right? We cannot use the gradient formula, right? If you are not going to use the gradient formula here, what is it that you are going to do then? We are not going to use the gradient formula. What is it that you're going to use? Then, of course, we must look. We don't have the parallel line. We don't have the perpendicular line. Then the only thing that we have is this angles here that AB makes with the positive x-axis. Now, what is this one here? That is our angle of inclination. Of course, now you remember now when you calculate this angle, you say tan theta is equals to M, right? Yes. Now, what is this M stand for? For the gradient. And this one here, of course, that is the angle that the line makes with the positive x-axis. Right. Now, let us now substitute here now to say we have the angle which is what? 45 degrees is equals to M. Then from here now, boys and girls, now look at this one. You're going to smile when we get to the answer here. Right, the answer here, that is tan of 45 degrees. What is tan of 45 degrees? Then it's 1. What is the meaning of this? What is the meaning of this? It means the gradient of AB. It means the gradient of AB, the gradient of AB is equals to 1. It means the gradient of AB there is equals to 1. Of course, boys and girls, remember now, if like we said earlier on, if you see that I don't really get this one right, remember you can just ask that question so that at least now in the next session now you can be able to respond to those questions. Right now, I think after break, we'll be looking at 4.2, which is also very interesting now because they said now we must calculate the value of T as well as 4.3. Boys and girls, now we're going to have the 5 minutes break, 10 minutes break. Now, immediately after this, now we are going to continue.